Assalamu alaikum. My name is Jami Sharir, and today I'll be talking about resource allocation graph. Okay, so uses for resource allocation graph. Resource allocation graph can be used for deadlock detection and deadlock avoidance. Alright. Okay, some features of resource allocation graphs. The first feature is they are directed graphs. Okay, and the vertices are labeled as V and the edges are labeled as E. The second feature is the vertices can be processes P or resources R. The third feature is edge can be either requested edge, which is the arrow that goes from process to resource, or assignment edge that goes from resource to process, the arrow. The fourth feature is the diagram elements representation, which is processes are represented by circles and resources are represented by rectangles. Alright, so let's look at an example to understand this further. So two processes P1 and P2 are given, and then two resources R1 and R2 are here. So if we look at the dots inside the resources, these are instances of resources that are going to be called by processes later on. We'll see that. Okay, so here this is a requested edge. This is because process P2 is asking for request R2, an instance of request R2. Alright, here we'll see assignment edge, which is an instance from R1 from resource R1 is being used and is being passed on to process P1. Alright, so let's look at the resource allocation graph algorithm. The first thing that we have to take notice is this is applicable if each resource has only one instance. So basically, inside the resource there will only be one instance. There will be claim edges from process to resources. Processes might request resource in the future, so claim edges are represented by dotted arrows. When a process requests resource, claim edge will be changed to request edge. Request edge will be converted to assignment edge only if the conversion does not lead to the formation of a cycle in the graph. Alright, let's try to understand using an example. Suppose P2 requests for R1. Can this request be granted? Okay, so the first thing we'll have to look at is, can R1 be assigned to P2? Here it is R1, and can it be assigned to P2? Okay, so let's look at this. Here, process P1 is using resource R2, and process P2 is requesting resource R2. So P2 is requesting resource R1. So let's change claim edge to request edge. So this claim edge will be changed to request edge. Alright, the claim edge has been changed to request edge. Request edge can now be changed to assignment edge. Alright, so request edge has been changed to assignment edge, and the resource R1 is now assigned to P2. The next question we have to ask ourselves is it not cyclic? So if we look at the graph, we can see that and the arrows are forming a complete circle, and so it is not true, and this is cyclic, and as a result, request for R1 to be allocated to P2 cannot be granted. Okay, let's look at another example. Suppose P1 requests for R1, that is process 1 requests for resource 1. Can this request be granted? So process 1 will be requesting for R1. So let's see this. Process P1 is again using resource R2, as we can see, and process P2 is requesting resource R2. So P2 is asking for resource R2. And so the first question we have to ask is, can R1 be assigned to P1? that is R1, can it be assigned to P1? So let's change claim edge to request edge, that is the dotted arrow will change to solid arrow, and then let's change the request edge to assignment edge, and resource R1 will now be assigned to P1. And now we have to ask the question, is it not cyclic? So we look at the arrows again and we can see that it's no longer cyclic, and so our answer will be yes. And finally, request for R1 to be allocated to P1 can be granted. So resource 1 can be allocated to process 1. And in this way, we can use resource allocation graph for deadlock avoidance. That's all. Thank you.